In this video, we are going to talk about some characteristics of a quadratic graph. So we can see an example of a quadratic graph right here on this left-hand side. And a quadratic graph is actually what we call a parabola. So the U shape that we see here, again, is what we call a parabola. Okay, so we're going to talk a lot in this unit about equations of quadratic functions. So the equation is the quadratic, and the shape of the graph is what we call the parabola. So that's that U shape. And in this example, we have a graph because, I know it's not on here, but these arrows would be pointing up. We have two different types of graphs that we could have. When the arrows are pointing up, we say that this graph is concave up. Concave just means curvy. You might have heard the word concave before. We use it just again to describe this round shape. So we say it's concave up when the arrows at the end are pointing up, but this parabola also can be flipped upside down and that U can kind of be pointing downwards. That's what we say that parabola is concave down. So we want to make sure we have some vocab here that is universal, that when we talk about parabolas, we all know what part of the graph we're talking about when we refer to the graph. So again, the parabola is the shape of the graph, and we talk about the graph either being concave up or concave down. So what I want to do now is I want to look at some of these points that are on our graph that we can see. I'm going to pick them out and I'm just going to fill in my X and the Y values on the table. So again, I'm looking for some nice whole number points here. So I see one. I'm just going to fill them in from the left to the right here, kind of one at a time. Again, picking out those points that are nice whole numbers and filling them in on the table. Let's take a second and go ahead and do that now. So again, I just took those X and the Y values from all those points on the graph and put them on the table. And if you look really closely at these numbers, you might have noticed that no matter what, my X values are going to keep getting bigger, right? That's what we were talking about as we go from the right to the left. My X values get bigger. But if you notice, the Y values definitely do not follow that same pattern. So if you can see some pattern that is happening with our Y values that we should be able to see is that all of these numbers tend to repeat in the Y, right? First they go down, right? 7, 0, 5, or -5, -8, -9. Those are getting smaller, but then all of a sudden they start to go back up again. And we can see that from the graph, that this graph is not just increasing or it's not just decreasing. It's both. And this point that's right here in the middle, the only one that doesn't repeat is the most important part of our quadratic equation, which is this one that's right down here. That point is what we call the vertex of the parabola. And this is going to be, like I said, the most important point on our graph. So when we talk about the vertex of the parabola, the vertex is either going to be the highest or lowest point on the parabola. Okay. And when we talk about the highest, we often call that the maximum point. When we talk about the lowest, we call that the minimum point on our graph. So in this case, our vertex is the lowest point. It's a minimum value. Okay. And that point's the most important point because that's where all of the mirroring happens that we talked about before, right? We can see again these Y values repeating kind of around that vertex there. And when we have something that is the exact same thing on one side as it is on the other, we call this graph has symmetry. So another important feature of a quadratic is that symmetry will always happen. Okay, the vertex is going to be that unique point in the middle, and then the Y values are going to kind of expand out beyond that. And another way that we look at the symmetry is through what we call the axis of symmetry. And the axis of symmetry is an invisible line through that vertex. So again, this is what we call the axis of symmetry, or here abbreviated AOS for axis of symmetry. So the axis of symmetry is just the invisible line that cuts the parabola in half. So again, it's this dotted line. I'm going to highlight it so we can kind of see it a little bit more. But again, goes right through the middle of that parabola. We can see that the left side and the right side would be exactly the same of that axis of symmetry. So when we talk about the vertex also is again in the middle, kind of we're talking about cutting our parabola in half. When we talk about the vertex is the point, right? So here our vertex is the point 1, -9, right? That's our vertex for this parabola. When we talk about our axis of symmetry, it's a line. So our line, we're always going to write it as x is equal to some number. And in this case, that x value is going to be the same as the x value for our vertex. So our vertex is a point, x comma y. Our axis of symmetry is a line, x equals something. So those three features, concave up and down, the vertex, and the axis of symmetry, are new vocab words for a parabola. But we have two other vocab words that we're going to talk about that are words that we talk about with all types of functions. Those are the x-intercepts and the y-intercept. So we know the x-intercept is the point or the points where the graph touches the x-axis. Something that's unique about parabolas, or that's different from parabolas to lines, is that a parabola, in this example, has two x-intercepts. So again, we say that the x-intercepts are the points where a graph touches the x-axis. So in this case, our x-intercepts are -2, 0, and 4, 0, right? Those are our two x-intercepts here. But a parabola does not always have to have two x-intercepts. It can have two x-intercepts. There might be opportunities where we see that our parabola only is going to have one x-intercept. And then there's also going to be cases where we're going to have 0 x-intercepts. Okay. And last thing I want to say about x-intercepts is we have a couple different names for x-intercepts that we're definitely going to see in this unit. We sometimes call x-intercepts roots. We also call them zeros. And we also call them solutions. So we have 4 names for 1 or 2 points on our graph. And last but not least, our y-intercept. Again, our y-intercept is a point. In this case, it's where we cross the y-axis. So we can see here that our y-intercept is going to be 0, -8. So those are some of the key features of a quadratic. We're going to be using these vocab words, and we're going to be able to pick out the vertex, be able to write the equation of that axis of symmetry. So let's go ahead and do some practice now.